Hello, this is Benjamin Gordon, an MD PhD student at the University of Illinois at Chicago College of Medicine. This video is part of our Survivors Advising Scientists educational program, a bidirectional educational platform meant to connect our communities and increase scientific literacy and engagement. Our goal is to bring everyone to the table for scientific discussions related to cancer science and therapies. This is module number 3 on experimental variables. When scientists perform experiments, they collect measured values as data. Variables are measured values that are tracked in an experiment. Variables must be easy to measure for a good experiment. Variables should be able to be measured in amount or severity. Now, there's two types of variables I'll discuss in this module. There's the independent variable and the dependent variable. The independent variable are measures changed by doctors or scientists. The dependent variable are outcome measures as a result of the independent variable. And I'll explain this more in the upcoming slides. So first, we're going to go over the independent variable. These are variables that are changed by scientists or doctors. It is a premeditated decision made by a human. That means it is thought out by a human beforehand. The independent variable typically stays constant throughout the experiment. So here, as an example, we could give one group of patients blue pills, another group of patients the pink pill, and therefore the pill type, what color the pill is the independent variable. Now, throughout the experiment, the pill could affect patients in many different ways, but the type of pill the patient is getting usually stays constant throughout the experiment. That's why we say the independent variable is typically constant throughout the experiment. And since it was decided by a human which pill a group will get, we call it the independent variable. The dependent variables are outcome measures as a result or in response of the independent variables. The dependent variables are experimental measures that are not decided by humans. So, continuing with the previous example, if pill type is the independent variable, the patient response to the pill could be a dependent variable. So again, we have the group with blue pills, a group with pink pills, and let's say you're tracking weight as a result of the pill type. So the pill type is the independent variable and the weight is the dependent variable. For experimental designs, experiments are procedures meant to interrogate a research hypothesis. The goal of an experiment is typically to decipher the effect of one single independent variable without the influence of other variables. An experiment must have a control group and an experimental group. These groups are basically the same, except they differ by the independent variable, or the variable that is decided by the scientist. So let's go over this a little bit more. We have the experiment, and within the experiment, we have the control group and we have the experimental group. The independent variable is held constant in the control group. For instance, the control group is getting the standard medication. Then we have the experimental group. The experimental group is the same as the control group for the most part, except we are experimentally changing the independent variable. For this example, if the control group is getting the standard medication, we're going to experimentally manipulate the medication so the experimental group is getting the experimental medication. This one independent variable is what differentiates the control group with the experimental group. Let's go over an example. Let's form a research hypothesis related to children and piano lessons. Our hypothesis is if children between the ages of 6 and 10 years old have 6+ hours of piano lessons per week, they will learn more songs than children who do not take piano lessons. So first, let's go over the control group and the experimental group. The control group are children 6 to 10 years old with no piano teacher. The experimental group, children 6 to 10 years old with 6+ hours of piano lessons per week. Now, the groups are the same. They're children 6 to 10 years old, but they differ with one independent variable. The control group has no piano teacher. The experimental group gets 6+ hours of piano lessons per week. So that's the independent variable, piano lessons. It's a human decision whether or not they are getting piano lessons. Now, here's the experimental measure, the number of songs learned by both groups. That's the dependent variable. It's the variable that is dependent on which group they're in. And for this, we're going to track the number of songs learned in each group. Let's put this in our flowchart. We have an experiment. We have the control group, which is children between 6 and 10 years old with no piano lessons. And we have the experimental group. We have children between 6 and 10 years old with 6+ hours of piano lessons per week. Underline the piano lessons and no piano lessons are the independent variable in these two groups. The dependent variable is in the middle, songs learned. That's what we're going to track between the two groups and compare. Now, there is a standard way scientists and doctors like to graph the independent and dependent variables. On the x-axis, we have the independent variable. On the y-axis, we have the dependent variable. Another way of thinking about this is we have the independent variable, the cause, and the dependent variable, the effect. Now, let's go back to our piano lesson example. Here on the x-axis, we have the piano lesson exposure. On the right, we have the experimental group, and on the left, we have the control group. Again, the groups are the same except the one independent variable, piano lessons, in the experimental group. On the y-axis, we have the numbers of songs learned, the dependent variable. In this graph, it looks like the piano lesson group is learning more songs than the group of children that do not get piano lessons. However, it's really important to have that control group there. Without the control group, we do not know if the dependent variable is a result of the independent variable. We don't know in this example, without the control group, if children are learning songs because of the piano lessons. If we were just to graph the experimental group by itself without any control group, yes, the children learn songs, but how do we know children don't learn songs without a piano teacher? Maybe they could go on YouTube and look up songs on the piano. Here's another important note on control groups. Just because an experimental group is called experimental, it does not mean a certain treatment will be more beneficial. This is also true in clinical trials. If a patient's getting an experimental treatment, it could be beneficial or it could not be beneficial. We don't know unless we can compare to a control. So here on the left, we have a similar graph to what I showed before. It looks like the experimental treatment, piano lessons, is causing students to learn more songs. However, on the right is another possible outcome. The control group here actually learned more songs than the experimental group. What if the children were so resentful that their parents were making them take piano lessons that they refused to practice at home? Meanwhile, the control students without a piano teacher were just naturally enthused to go onto YouTube and look up piano songs. This is a possibility. That's why it's important to show both the experimental group and the control group. So when you look at experiments at poster sessions or papers, make sure you know you're comparing the experimental group with the appropriate control. So when you're evaluating scientific data, here are some questions to think about. What are your independent variables? What are your dependent variables? What would it take to reject the null hypothesis? What would it take to accept the alternative hypothesis? This is the end of this module. I'd like to take this time to thank Dr. Kidieski and the administrative staff of the University of Illinois Cancer Center for their support in this effort. Additionally, we'd like to give a special thank you to all the cancer patient advocates who provided feedback in the development of these modules. We'd also like to thank you for reviewing this module, and we invite you to send any additional feedback on this module or suggestions for future content. Please feel free to move on to the next module, number 4, on confounding variables. Thank you very much.